thyroid stimulating hormone, will be produced and released from the thyroid gland. The thyroid hormone will circulate and be bound to an intracellular receptor and affect the transcription of a lot of genes and increase metabolism in those cells, fuel use and fuel burning. So here a little more breakdown: increased cardiac output. You know all about that stuff. Increasing what blood is getting pumped out, that increases blood pressure as well often. But it comes at increasing cardiac output from all the channels really. Increasing myosin even, the activity, increasing ion channel activity, the receptor, beta-adrenergic receptor activity, really increasing all of the transmission and the rate, all the parts of cardiac output will be increased, will be maintained, and can be increased by thyroid hormone. And so it's important to realize that you have a constitutive production with peaks to meet needs to some degree. So here's one of these tables, if you like this sort of thing, that has, and I do, that has all of these. It will also have hypo and hyper secretion, which if you know the function, you know what decrease or increase would do. So all the different things that it does, but I think that just to kind of glance at it, you see promotes glucose catabolism, that's mobilization of fats, burning, that's kind of burning, ATP production. But look at a lot of these other ones. Nervous system promotes normal development and function. Cardiovascular system, normal function. So there's that, just keeping that, helping to keep that all working, from contraction to contractility. Muscular system, development and function. Skeletal system, growth, maturation. So if you drive cellular work, if you drive cells and you provide nutrients for them, and then you provide just that, the transcription of the genes that enhance those functions, all those enzymes that help make ATP, then you're just kind of providing a driving force for all cells. And so that just helps maintenance. So this is one of the reasons why people will feel better on work. When they don't feel good, kind of systemically, one of the first things you do, other than vital signs, BMI, looking at their past medical history, present medical history, current medications, you go, well, let's just see what your glucose looks like. You might check their A1C, TSH. Let's just, you just kind of start there, and you'll order TSH so many times because you see what thyroid function is doing everywhere. And then you get the information, and then you have to figure out what to do with it. So that's thyroid gland, really. It's thyroid hormone. It does that other thing, though, and so it has. I'm sorry, I mean to say we also have parathyroid glands, and I want to connect what parathyroid glands do before we get to them. So 99% of calcium is in bone. You have to have a blood content or an ECF level, and its normal blood is 9 to 11 deciliters. The two hormones that regulate calcium balance are calcitonin and parathyroid hormone. So let's look at parathyroid glands. So on the posterior surface of each of the lobes of the thyroid gland are these parathyroid hormones. And they're really just kind of discs of tissue. 4 is a normal number, but you can have other numbers. So 3 to 7 is not even abnormal. People can have more than one. So that's not really ever anything that you look at in terms of the glands themselves. These are, function is really the only way you're able to determine about them. I have heard of a parathyroidectomy. I think that, typically they can go with the thyroid gland, but someone specifically had a parathyroidectomy in a past medical history, and I thought that was interesting. Somebody was just chasing something, I think, in a way, and I don't mean that in a negative way, but the things that you know, we don't hear often. There's some expert that has that theory or plan with that. But for, so these discs of tissue embedded in the posterior thyroid, and there are chief cells, that's kind of the main one. This is the abundant granulated cell, so you know it's going to be the thing that has all the vesicles of parathyroid hormone. And then also oxyphil cells, and those are just kind of interesting. They're big, they have weird shaped mitochondria. The function isn't super well known. It was thought that they helped the chief cells. It was thought that they destroyed chief cells. There's just been, you know, not a particular consensus for activity, but they appear at puberty increase with age. So, you know, there's the decrease of thyroid function occurs with age, and increase in these cells occur with age. Not necessarily a connected thing, but certainly they're at the level of the thyroid. So that's just a sort of an aside to the whole thing. But so there you see a little parathyroid gland kind of embedded in this thyroid tissue. So that's kind of, I mean, you see in this picture how it's sort of just really embedded there as part of the thyroid hormone. Parathyroid hormone is a protein hormone. It's the single most important regulator of calcium balance. So calcitonin is not primarily functioning to balance calcium in the blood. It's really parathyroid hormone. And I always write PTH for that, so if you see that in slides, that's what it means. So its release is stimulated by falling blood calcium levels. So it's the parathyroid gland itself. It doesn't have hypothalamic or pituitary control over it. It itself is causing its own production and release of parathyroid hormone. So falling blood calcium levels stimulate its release. And concomitantly, increasing calcium levels would decrease its release. The receptor, it's a protein hormone, so the receptor would be found on cells in the cell membrane, transmembrane receptors, and it acts, they're a second messenger, in this case cyclic AMP. And there are 3 target organs for parathyroid hormone, and we've really touched on this during renal, I believe, and maybe again probably in GI. But in bone, it will increase degradation of bone, so increased cellular activity to degrade bone. So you know bone is out there, but there are bone cells, and then there's a protein, like a collagen matrix, upon which there are plenty of ions deposited. The majority of that is calcium. You can degrade that and demineralize the bone of calcium and put the calcium in the blood to maintain that blood level. You can increase the absorption of calcium at the level of the small intestine. And you really do that with the activation of calcitriol. So do you remember where vitamin D came from? Like the skin, and then the liver, and then it was ultimately activated to calcitriol in the kidney. So, and then you also have exogenous vitamin D that we would eat, like plant calciferol, and we convert that in the liver and the kidney as well to vitamin D. So skin is the source, and the ultimate activation is via the kidney. So you can, so parathyroid hormone can increase that activation of vitamin D, to active vitamin D by the kidney, and that will then help the small intestine uptake calcium. And the kidney, you can just try to reabsorb it from the filtrate. There will be also deposition or secretion of phosphate as a result of that. And then you can also get the kidney to activate vitamin D, which I just said. So those are the places that you can control calcium, bone, absorption, and secretion. And so that's what parathyroid does. It acts at all of those levels to maintain calcium levels. And that's really the only function of that whole thing, the parathyroid hormone, parathyroid glands. So this reminds you of the synthesis, that you have a plant source from an endogenous dietary source, or you have cholesterol being converted in the skin to a pre-form of vitamin D in liver and kidney. And that's going to go on, but parathyroid hormone will enhance the activity of that. So there'll always be a little low-level parathyroid hormone, but it can increase when calcium levels get low. The action of calcitriol, how does it specifically then work if it's made in the kidney? It will circulate and bind to the VD receptor. Do you guys ever remember VD being venereal disease? And then it was STD, the sexually transmitted disease, and now there's a little bit more discussion to sexually transmitted infection, because people don't always have disease symptoms but can have the infection. So anyway, VD. Also Victory Day for World War I, right? Victory Day, World War I? God, that's really bad. So anyway, there goes World War II. Anyway, here it means vitamin D. Vitamin D receptor is in the nucleus of bone and small intestine cells. So cute, it's an intracellular receptor because calcitriol came from cholesterol. So it's going to be a steroid hormone that crosses the cell membrane, and it will bind and alter the rates of transcription. It will increase the activity of osteoclasts, increase absorption of calcium, and it seems to help increase the proliferation and differentiation of immune cells like Bs and Ts. So there is, vitamin D. Oh, there's always a popular vitamin. Vitamin D is really still spoken about, like it helps with everything, it's better. But I just do think if we have adequate levels and everything's functioning, health is enhanced. So I think that's fine. And then I told you about someone when we were doing the nutrition specifically, that the PA was recommending like a 50,000 dose of vitamin D for repair and bone. So, and I think it's fine if you can tweak things like that if there is evidence in the literature. So anyway, vitamin D. And as people get older, they often have less. I think some of that comes from not ingesting as much plant material, because it's maybe a little harder on folks' digestion, not being outside as much, slowed activities, and so this is one of the things that we try to enhance in the diet is vitamin D and calcium. Anyway, how do you regulate parathyroid hormone? Circulating calcium levels, when they're adequate, will feed back and inhibit its production. And also calcitriol will feed back and inhibit production, because really, when you want it normal, and you want calcium normal, but boy, you hate to degrade bone too much, so that's kind of a balance. Of course, homeostasis, balance, that's what that all is, so there you go. Okay, so that was that, and I wanted to put parathyroid before calcitonin to make the point that it's really the most important in calcium control. And then let's go back and talk about the thyroid gland. So the thyroid gland made thyroid hormone, and it also will make calcitonin. So it's a protein hormone, so that makes it different. It's not an amine type hormone like thyroid hormone. It's made by perifollicular cells. So there were the follicle cells that surrounded the colloid, and those are making thyroid hormone. But then there are a smaller population of cells that are around those that will make the calcitonin. And it will be, if calcium levels get too high, calcitonin will help lower them. And it will help mineralize bone, so you can take calcium out of bone and mineralize bone, put it there, or enhance or decrease or not increase the reabsorption at the level of the kidney. I always thought of calcitonin, calcium in bone, and then parathyroid was calcium out of bone. But parathyroid's the big one for calcium regulation, because really having too low is more common than too much. And so, but it is true that that's the other thing that the thyroid gland does. So you can imagine that if somebody has an ablation of the thyroid or thyroidectomy, then you have other things to take care of besides just their their thyroid hormone addition. And so I think that that can be kind of not remembered always, or put on the thing, on the radar screen, I think. So here is a summary of calcium balance. Parathyroid hormone increases plasma calcium, calcitonin decreases plasma calcium in all the ways that I just told you. Yes? So that was, I believe that's the end for thyroid gland. Oh, here's just a picture. Oh, look at all the small intestine there. Okay, so we did, this is physiology. The introduction, hypothalamus, pituitary gland, thyroid gland, parathyroid gland, and then the adrenal glands. And you will just cue that information up, won't you?